Okay, this exercise is about using the sandwich or the squeeze theorem. The limit we're asked to find is the limit of x squared sine square 2 over x as x goes to 0. First of all, we know that the sine function is bounded between 1 and minus 1 on the other side. So this goes for any argument. In particular, the sine of 2 over x is bounded between 1 and minus 1 on the other side, as I said. And now if it is a sine square, since the sine squared cannot be negative, so this is bounded between 0 and 1. Now I will just multiply by x squared all out, and since x squared is not negative, then I will not change the direction of these inequalities here. So I can say now 0 multiplied by x squared is 0, is less than or equal to x squared multiplied by sine squared 2 over x, less than 1 multiplied by x squared, which is x squared. Now let me just check the limit of the function 0 and x squared on the other side. So what's the limit as x goes to 0 of 0 is equal to 0, of course, and the limit of x squared as x goes to 0 is also 0, and therefore this must go also to the same limit, which is 0. So the limit of x squared sine squared 2 over x must be 0, of course, as x goes to 0 by the sandwich theorem. Okay, the limit that I have here can be split into two limits if, of course, they both exist. The second limit of which is simply the limit of 1 over x squared minus 1 as x goes to infinity, which is obviously 0. For the main limit here, which is the limit of x multiplied by e to the sine x over x squared minus 1 as x goes to infinity, I am going to use the squeeze theorem. And first of all, I realize that sine x is bounded between 1 and minus 1. It is well known. So now I will just concentrate on e to the sine x, which can be bounded between e to the 1 and e to the minus 1. Now I will multiply everything by x over x squared minus 1, and this quantity is supposed to be positive because the limit is going to infinity. So if I multiply everything by x divided by x squared minus 1 times, of course, 1 over e, which is e to the minus 1, this is less than or equal to x divided by x squared minus 1 e to the sine x. So, and I'm not really changing the direction of the inequality signs here. So this is less than or equal to x divided by x squared minus 1 multiplied by e. What I will do now is I will just take the limit of the extreme left hand side. So this is the limit of x divided by x squared minus 1 multiplied by 1 over e as x goes to infinity, and obviously this is going to be 0, right? 1 over e can be taken out, and the limit of x over x squared minus 1 is obviously 0. The same thing happens here. The limit of x divided by x squared minus 1 multiplied by e as x goes to infinity is also 0. Then it is true that this limit must be 0 also, and therefore as x goes to infinity is 0, and therefore 0 plus 0, 0 plus this 0 must be 0, and the answer is just A. Okay, here's another exercise that requires the use of the squeeze or the sandwich theorem. Let me take the limit of this side first as x goes to 1, and we can see that the limit as x goes to 1 of x squared plus 1 is obviously 2. The limit of this side is also 2. The limit of 3x to the 4 minus 1 as x goes to 1 by direct substitution, of course, is equal to 2. Therefore it is also true that this limit must be 2. So the limit of f of x minus 2x as x goes to 1 must be equal to 2. But this limit can be split into two parts. So this is the limit of f of x as x goes to 1 minus the limit of 2x as x goes to 1. Everything must be equal to 2. But the limit of 2x as x goes to 1 is also 2. Therefore, it is true that the limit of f of x as x goes to 1 must be equal to 2. And then 2 from the other side, that should be 4. Well, more on the squeeze theorem or the sandwich theorem. I'm given f of x between x squared plus 3 and 2 multiplied by x plus 1, and I'm asked to find the limit of f of x minus 4 divided by x minus 1 as x goes to 1. Now I don't have that expression ready, so I will just cook it up here by first subtracting from 4 from all sides. Okay, and if I do that and then try to simplify here, I will have now 2x plus 2 minus 4, which is minus 2, less than or equal to f of x minus 4, less than or equal to x squared minus 1. And if I just take a common factor as 2, so this is 2 multiplied by x minus 1, less than or equal to f of x minus 4, less than or equal to x minus 1 times x plus 1, which is a factorization of x squared minus 1. Now, if I divide by x minus 1, the problem here is I do not really know whether x minus 1 is positive or negative. So in this case, I will consider the two sides of the limit, which means that the limit as x goes to 1 from the right hand side and the limit as x goes to 1 from the left hand side. Now, in the case that I take the limit as x goes to 1 from the right hand side, I know that x minus 1 has to be, of course, positive because x is more than 1. And therefore, if I divide by x minus 1, nothing will happen to the direction of the inequalities. And I can simply write 2 times x minus 1 divided by x minus 1 now is less than or equal to f of x minus 4 divided by x minus 1, less than x minus 1 times x plus 1 divided by x minus 1, which with simple cancellation will result in 2 less than or equal to f of x minus 4 divided by x minus 1 less than or equal to x plus 1. Now, if I take the other limit, which is the limit as x goes to 1 from the left, then I know for sure that x minus 1 has to be less than 0 because x is less than 1, and therefore I need to change the direction of the inequality of the inequalities here. But if you observe that I can take the limit, of course, if I use any one of these relations here, and then take the limit as x goes to 1, you can see nothing changes on the left hand side. So this is the limit as x goes to 1, and whether it's this one or this one, that's supposed to be 2. And if I also do the same thing here, the limit as x goes to 1 of x plus 1, this is also 2, then it is true that the limit of this function, regardless of the direction of the inequalities, is going to be 2.